Hey all, in this lesson we're going to talk about different types of proportions that exist within triangles, and they can help us at times to find missing side lengths or missing lengths of pieces of a triangle. So one thing that creates proportions in triangles are parallel lines, and over here I have a triangle that has a segment that goes through it that's parallel to one of the sides. Now remember, those arrows mean that those segments are parallel to each other. So we have this proportion created that this side QR, or this piece QR, divided by this piece RX is going to be equal to QS over SY. So you'll be given lengths of these pieces. Some of them might be a variable. What I like is that this parallel line here in the middle kind of creates a fraction bar if we extend it. And that'll be easier to show when we do one that has numbers. This isn't a triangle, but the same relationship exists here if I have several parallel lines. Again, the arrows are telling me that those lines are parallel to each other. And I have all these proportions created. AB over BC, so those lengths will be equal to WX over XY. And if I have more and more parallel lines, I can write more and more proportions in the same way. And again, these pieces here sort of create fraction bars, and when we have values placed, we can sort of see the fractions, and that'll be easier again. It'll be easier to see when I give you an example. Another type of proportion in triangles is formed when we have an angle bisector. This angle bisector kind of becomes a natural fraction bar for us to create a proportion. We have that AC, this side over here, over AB, the other side, will be equal to this piece CD over this piece DB. So this angle bisector creates it cuts this side so that those little pieces are in proportion to the two other sides that aren't broken up. So let's do a couple examples using these proportions. And again, I told you this is going to help us find a missing piece. So we're looking for this piece right here. We want to know how long it is. And I also mentioned that this parallel line in the middle that's parallel to this side is going to kind of create a natural fraction bar if we extend it on both sides. So I can write a ratio here to find x. 8 over 10 equals 6 over x. And now I'm just doing what we did when we were solving proportions. I cross multiply and get 8x. 6 times 10 is 60. And then I can just do one more step and get that x is 7.5. So again, if I extend this parallel line in the middle, you can see we have kind of a fraction created here, 6 over x and 8 over 10. And because these two segments are parallel, those fractions should be equal to each other. So go ahead and pause here and use the same idea. I want you to find x. So again, we have a parallel segment in the middle of the triangle parallel to one of the sides. If I extend that segment, I've made sideways fractions, so I can say x over 10 is equal to 15 over 30. And the tricky part here is that I chose x from the right side of this segment to be on top, so I have to have 15 from the right side of this segment to also be on top to make sure that our ratios are actually equal to each other. So I cross multiply, I get 30x, equals 150, and I get that x is 5. Here's an example using our angle bisector. Again, I know this is an angle bisector because of the two congruent symbols there telling me those angles are congruent. That means this segment has bisected that angle. And I can create fractions. 12 over 10 is equal to x over 5. I'll cross multiply. 5 times 12 gives me 60. 10 times x. Solve and get that x is 6. So you know what to do here. Go ahead and pause and find x. Use the same idea. I'll give you a hint. This is definitely an angle bisector. I've shown that those two smaller angles are congruent to each other. So I'm going to extend this angle bisector and find myself a fraction of x over 3 and 8 over 5. Again, from the left side of the fraction, I chose x to be on top, so that means that 8 from that same side is on top. You can cross multiply. And I'm going to get a decimal here. I'm going to get that x is 4.8. It's always okay to have lengths that are decimals. We don't live in a perfect world, so decimals are okay. So I got two for you, one example of each. For the you do them both. Find x. Use the examples we just did to help you, and I'll answer your questions in class.